This is homework number 7, problem 3. We're going to graph a function, and this is an exponential function. F of x equals 4 to the x power. It's an exponential function because the exponent is the variable. It's the thing that's changing or the thing that we don't know, rather than the base. And the best way to do these is just to make a t-table, a chart of input and output values. So a lot of times we just make our inputs values close to 0 because these are the easiest to work with. They're small numbers. 0 is easy to put into a function. But let's show the work for this problem so we understand how the outputs were gotten. I always start with 0 because inputting 0 into a function, like I said, is usually very easy. So in place of the x in 4 to the x power, I've put a 0. And if you remember from back in homework number 1, lecture 1, anything to the 0 power, except 0 that is, anything to the 0 power otherwise is 1. So input 0, output 1. Let's put in 4 to the first power, putting 1 in where the exponent was. 4 to the first power is just 4. And now we're going to put in 2 for the exponent. Again, we're replacing x each time with the input given. And 4 squared is 4 times 4, or 16. Now let's go to the negative numbers. 4 to the negative 1 power. Again, if you remember from homework 1, lecture notes 1, a number raised to the negative power is the inverse of that number to the power. So it's 1 over 4 to the first power. 1 over 4 to make the power positive, which is just 1/4. And then 2 to the 4, we're using 4 for the base every time. Go back to your function. 4 to the negative 2 power is the same as 1 over 4 to the positive 2 power, which is 1 over 4 times 4, or 16. So input negative 2, output 1/16. Negative 1 input, output 1/4. 0, 1, 1, 4, and 2, 16. Now I plot these. These are coordinate pairs. Any one of these I could relist. For instance, negative 2, 1/16. I could relist it as a coordinate pair. But you can just look at them and see that. This is the input, x, this is the output, f of x or y. So now I go to my grid, and there's a number of ways you can graph these. Since I have very, very small inputs and very, very large inputs, I might want to, perhaps skip spaces. Am I going to make it? No, I'm not going to make to 16. So I'm going to make every notch 1 unit. So therefore I don't need to number them. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. I like going by ones, even though on the answer key they went by 2s. But if you've got plenty of graph paper, why not be more accurate? And then on this axis I'm going to go 1, 2, 3, 1, 2. So 1, 2, 3, negative 1, negative 2, negative 3. Again, I don't really need to number those if I'm going by 1 unit. Alright, so my first input was negative 2, 1/16. Go left 2 and up a 16th. Now remember, this is 1, so a 16th is very, very tiny in relation to 1. So I'm not going to go very far off of the x-axis. My next value, negative 1, or my next coordinate pair, 1/4. So left 1, up a 1/4 of this space, a 1/4 of that space, so not very far again. Exponential relationships really tend to hug an axis for a while before they leap up. Next input output is 0, 1, so don't go left or right, that's the 0, and go up to 1. So right there on the y-axis. That's our y-intercept, by the way. The next pair, 1, 4. So go right 1 and up 1, 2, 3, 4. Now the function is really starting to leap up and grow. The next pair is 2, 16. So over 1, 2, over 1, 2, from 0 and up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. Now the function is really leapt up. And you want to connect these points with a gentle curve, which is now easy, especially where they get really far apart. Whoa, you went off the road there. Didn't do so well with that. Do the best you can. And you always want to put arrows on the ends of your line, your curve, to show that you understand it goes into infinity in both directions.